Electron configurations for ions. You need to know how to write electron configuration for elements first before looking at this video. Let's just remind ourselves how ions are formed. Ions will either gain or lose electrons. The number that they gain or lose is tied into the fact that they want to mimic the noble gas. You'll need to be looking at your periodic table as I go through these problems so that you can use the periodic table as a cheat sheet on your next exam. If you look at calcium, it makes a +2 ion and it has 20 protons. Because it's a cation, that means that it removes electrons. How many removes is tied into its charge. It has a +2 charge. It means it removes 2 electrons. As an ion, then, it has 18 electrons. It also mimics the number of electrons that the noble gas argon has. Sulfur with a -2 charge is an anion. That means that it needs to add electrons to itself. And you're going to add 2 more electrons onto sulfur to get a total of 18 electrons. Remember, never change the number of protons when you're doing ions. It's only electron numbers that change. Again, this anion has the same number of electrons as argon. Let's look at the rules for writing ion configurations. Cations will lose electrons. The number of electrons that they lose will allow them to attain the same number of electrons as the previous noble gas. So cations mimic the previous noble gas. Anions gain or add electrons. They're going to gain and add the number of electrons needed so that they will attain the same number of electrons as the noble gas that comes after them in the periodic table. Let's look at this electron configuration for ions using this periodic table. We will only be using those elements found in group 8A because those are the noble gases. If we did barium with a +2 charge, we would notice it was a cation. And the rule is that cations mimic the previous noble gas, or the noble gas that comes before them. So barium, cation, mimics the xenon noble gas. You can prove that it does if you look at how many protons and electrons this cation has. It has 56 protons, and the number of electrons it has would be 54, which is exactly how much xenon has. If you look at aluminum with a +3 charge, again, it follows that it will lose 3 electrons to mimic the previous noble gas, which is neon. So the cation aluminum mimics neon. Potassium with a +1 charge then will lose 1 electron to mimic the noble gas argon. Doing electron configurations for ions, these will add electrons to mimic the noble gas that comes after them. So again, you will be looking at group 8A. Phosphorus with a -3 charge will gain 3 electrons to mimic the noble gas argon. Oxygen with a -2 will mimic the noble gas that comes after it, which is neon. Iodine with a -1 charge gains 1 electron to mimic the noble gas xenon. Looking at these anions and cations, when you're looking at your periodic table, you will notice that they will gain electrons or lose electrons to attain a noble gas. So happen that they mimic the same noble gas called neon. So cations and anions can have the same ion configuration. These are called isoelectronic.